Hi, everyone. Welcome back. During the break, someone asked about the actual slides. So I actually built, these are built in Quarto. I think I'm saying that right at this time. The new, if you've used R Markdown before, it's kind of the new version of that. These are, they're HTML-based slides. I'm trying to remember which of the HTML slide versions these are. I'll have to look it up. But there's a couple options, and you can do some cool stuff like you can embed a lot of the HTML features we're talking about today in our Shiny apps. In these, it does kind of make the size of these files really big, so I tried not to do that. But you get nice things like the code highlighting and some scrolling and stuff. So
how do you spell it? Someone was asking about chat.
Quarto. Quarto.
Q. Can you say that again?
Quarto.
Quarto. Quarto. Okay.
It's like part of presentation is like one of the options when you create RStudio.
Right.
Yeah, and I'll look up what the specific type of version, but that's a very new feature or a very new kind of R, and it's beyond R. You can use it with like Python and different languages as well. But yeah, it makes nice presentations.
Nice. Someone in the chat just put a link out there. So
awesome. Thanks for that question. Okay, so we're gonna jump into a little bit. We're gonna return to our example here, and we're gonna go to a little bit more advanced features. So we're gonna jump into what we're going to call reactive expressions. So our goal here, so say we got this table in our app, we have these selections. So say we want to add a plot as well to go along with the table that will display the information for the different counties. So our new goal is going to add a graphic that plots the outcome for the different counties that the user selected. We're going to also add a user input option to add a reference line, sorry for the typo, that shows all of California relative to the different counties. So I didn't point this out, but one of the rows of data in our data sets says California rather than the counties. That is kind of the overall California line. We're also gonna adjust the UI to accommodate the plot and add a dynamic title to the plot as well. So let's jump into those different options. So to do this, we're going to add an element to our server that is called reactive expressions. So sometimes we want to create an intermediate object into the server that is something that we'll use in different places, but not necessarily something that we're going to directly output. So this could be kind of an intermediate data set, a model, some sort of object that we're going to use kind of later on, or that can be used by multiple pieces. So a good example of that, right? We're creating a data set by filtering by the year and by the input. So we may want to use that for both the output table and our graphic. So to do that, we're going to use a function in the server called reactive. This is going to look a lot like those render functions. It's going to have a parentheses and the curly brackets. We think of reactive very similarly to those render functions, like defining a function. And we need those two sets of brackets, as we talked about. Okay, so what does this look like? So this is going to be what we're going to put in our server. So what we're going to do is I'm going to add an object, a reactive object, which I'm going to call data sub, which is going to subset our original data sets that we loaded in by the given year that we selected, and filter it to the selected outcome. So this is similar code that we had in our reactive table part of the server. I'm just pulling it out into its own reactive object. Okay, so now this data sub is going to represent the subset of data. The second thing I'm going to do is I'm going to pull out from our subsetted data just the California line that we're going to use later on in our plot. So we can actually make a second reactive expression here that uses the first reactive expression. And we actually do that. The important part here for using data sub further on is we need to call it like a function. So data sub has to have these parentheses around it that actually calls the value of it to be used later. So we're going to use that reactive expression data sub, and then we're going to filter it to the California, and we're going to grab the rate or percentage for California for the given indicator. We're also going to take that data sub, and we're going to eliminate the California row from it. So I'm just taking that data sub again, filtering to the county that is all the counties that are not the full state of California. The last thing, that reactive expression that we're going to use is going to be a plot title. So this is going to, we're going to have a dynamic title to our ggplot, which we'll add, which is just going to say the rate of the selected outcome in the given year. So this is something that we could put directly kind of in the render statement, but I'm going to pull it out here just as another example of a reactive statement. So let's look at what this looks like in our updated code. So I didn't put this directly in the slide because we're starting to get into a place where we have lots of code. So we've changed our look of our UI here during the break. Hopefully this is a little bit better. So we're going to look at example 10 here. And I'm actually going to pull up all the different pieces here. And I'm going to run this first, and then we'll look more specifically at the code and remember to set the working directory. All right, so we had our two tabs. We're still in our second tab here. And we're going to have a ggplot object of our output with our different options. It's going to change based off of our inputs and our outcomes. And then we have this option here, which is, it's kind of faint, but there's a vertical line here, which indicates the value for California. Our different California counties are on the y-axis here, and then the value of the indicator is on the x-axis. And then we also have, we're going to have a dynamic title here as well. Okay, so a lot going on. Let's walk through the code that got us there. All right, so first off, all right, starting with global as kind of rehashing the steps to build the app, right? This is all the same. We've loaded the data. I guess the only thing I did add a library statement with ggplot2 to load that in. Okay, then what I did was I added a function to global that's going to be what I would refer to as maybe a helper function. So this is, you know, trying to separate out code a little bit to make things a little bit cleaner in our servers and our UIs. So this is a function that is going to take the data, our reference for California, the name of the variable we want to use, whether we want to use the reference line or not, and a title, and construct a ggplot object. So one thing that's nice about pulling out and defining these kind of custom helper functions is that we can actually test these things outside of our dashboard. So if we want to go back to that question of like, how do I debug if I find issues? One recommendation to do that is try to define where you can functions outside of your dashboard so you can actually test them outside of your dashboard. So for example, I'm going going to stop this momentarily. Ooh, I accidentally deleted that. We could figure out how to run this. And just going to temporarily add a new R script. I'm going to grab my arguments here. So if I said my data, remember what the names of our thing is. Cal, county rankings 21, reference. This is actually going to be a number. I'm just going to make it up for now. Use the reference line and should be able to call this. All right, so this is a little ugly, but you can get the idea that this function is going to be what we're going to be using. We use in our dashboard or our app, and we can test that outside. So this is one of those places, you know, there's some specific ggplot code, which we could dive into a little bit. So then one important thing to know here, right? We're not using anything, I'm defining this function. I'm not doing anything that's specific to RShiny here, right? I'm just defining a function that creates a ggplot, right? So, you know, for example, you could use this in other places, and you know, just knowing that there's nothing specific we're using here for RShiny. One of my colleagues that was newer to learning RShiny, as I was describing all these helper functions, she said, "Oh, you know, RShiny is just like a function factory for R, right? We're making a lot of these helper functions, we're plugging them into our app, and then we're using them." So really getting comfortable writing your own functions is going to be really helpful as you kind of progress in your own RShiny journey. Okay, so that's global. So we added this into this helper function. Okay, so what have we done in UI? So we added
Sorry, we had a question. Why write the plot function and the reference line code in global.r?
I think this is to some degree personal preference. So there is an advantage to having it here versus in server or UI. So everything, remember that global gets run once when the app starts, whereas things in server and UI can get run multiple times. So this is one of those places where you could be saving computation by it getting run once, it's in working memory, and then it doesn't have to get rerun. But some of it, you know, it's not going to make a big difference if we defined it within server UI for this particular use case of defining a function. So some of it's just preference of where you put things. Sometimes I will even like separate these helper functions in their own file and then call a reference to that file in global. So some of it's just kind of housekeeping. Good question. Okay, so we said we were adding an option to include that California reference line in our plot. So to do that, I've added a checkbox input after our two other input selections. Right, this needed that input ID. I've actually forgotten to put the name of the parameter there, but the label and the value, we're going to default it to true. And we're going to give a direction to the user, include the California reference line, and then the rest are text output. So before we jump to our output, just following our steps here. So what's happening in our server? So in our server, we've kind of manipulated some of the steps that we had here. So first of all those reactive objects that we talked about on the slide, I put at the top here. So our subset of data, that is just the specific year and the specific outcome. the California value, and then the data that is not California coming from our subset of data, our plot title. And then we have our same output of our text selections. Our output table is now a little bit simplified, right? Before we were actually doing the filtering within this render table. Now I can just simply directly use this reactive variable where we already subset the data. And remembering that we need to use the parentheses here and selecting the right columns that we wanted. And then the last piece is the new piece that we have. So, right, this is a plot. One of the options that we had in terms of our render options is the render plot. So we'll use that here. And here, basically, I'm just calling that function and plugging in the values that we defined either from the user inputs or our reactive variables here. So I'm saying the value for data is the subset of non-California data of our particular year and outcome. That reference line is that reactive value that we defined just for California. The rate variable is just pulling the right column for us. The input use Cali reference. Okay, so one thing to point out here, when we defined in the UI, right, our checkbox, on the backside of that within the server, this is either going to have a value of true or false. So that's something to remember. We set it to default to true here. So this is going to either say true, false, using that input, right? Remember that the reference that we're using for input needs to match the value here, use Cali reference. And then the title, which we're pulling from the reactive value, which we named plot title, matching the name of the reactive up here. And we're naming this new output plot, very descriptive there. And so that next step we have is placing that in the output. So the last thing we're doing here is, that's our table output. So I've swapped around what goes where. I put in the main panel the plot output. So that paired plot output function with the render plot. And we're going to put that in the main panel. And then we're going to put the table output below that. All right, so that is all of our new code. Let's go back and look at the app one more time. I know we're getting more complex in there. There's a lot there. So make sure we get it right. So, as we change our inputs, right, we get all of our output here. So we have a lot of dynamic outputs at this point, right? So we have our text here, we have our table, we have our plot. Within the plot, we have this line with the California reference, and as well as the name of the plot, the title, changing as we change the inputs. Question?
I'm not sure if this is referring to one particular element or not, but this question is, why use a reactive object versus just a regular object?
So let's go back to the code for a second. So the question was why we're using a reactive element here. Why can't we just say something like data equals this? The basic answer is this doesn't work in RShiny. So anytime you're using these input objects, anytime you're using anything reactive, you have to tell kind of the system or the RShiny that it is something that needs to change over time. Basically, this is gonna, if we try to run this, it's gonna yell at us. or it's just gonna give an error, right? So if we look back at our studio, it's going to give us maybe a helpful error. So it's going to say we can't access a reactive value year outside of a reactive consumer. We want to wrap that in something. So basically what it's telling us is, you know, anytime we're using something from the input or another reactive variable, it has to be either inside of one of these reactive statements or inside a render statement here. So for example, you know, if you wanted to see, you know, if you're trying to debug, right? And you said, oh, I want to understand what the value of one of the inputs is at any given point in time. Let me undo this code quickly. So if you were like, okay, I want to understand what the value of selected outcome is. You say, oh, maybe I add a print statement. Right. Similarly, R is going to get mad at us and say, this needs to happen within a reactive statement. So it's saying we can't access selected outcome just anywhere in the server. It needs to be inside one of these reactive statements. So we could do the same thing, but it has to be within a reactive statement.
There's a follow-up question on this as well. Around reactive versus render. And this is asking, technically what can go under reactive can also go under render, but we're just using reactive to save computation. Is that correct? That was sort of a statement or a question.
Yeah.
Form of a statement, but...
So here's our actual print statement now that we put the print statement in the reactive. So we can see the print statements in the console when it's in reactive. So the question, yeah, just to repeat that. So why would we use a react? We can either, you know, do this within the reactive or the render. So why would we make a separate reactive statement when we could just do it within a render text? So in terms of computation, I don't know if it, you know, there's going to be some examples where we're doing things, you know, say for example, let's say this plot title, right? It's very simple. We've pasted this together. We could alternatively put this directly here, right? That one's not making it, it's not going to make a big difference computationally where that lives either way. There are some places, so say for example, you know, we're subsetting this data, we're making a table, and that's going two places. In one circumstance, it's going to our output table. So in our render table, right? We're using our data set, but also in our render plot, we're using that same data set. So if we were to directly use all of kind of just the base inputs plus our data sets, we would have to do the same computation twice rather than doing it once and having it go two places. So I think, you know, there are going to be examples when you're going to save computationally. The other thing I'd say is just kind of like organizationally, it can help kind of break down complex code into smaller pieces, and that can be valuable on its own for its own purposes, just to make things into smaller chunks as these apps get really complicated, to kind of break the concepts up. Good question.
So I got one more. You're up for it. So this person says, I put a browser statement where you meaning Robert. So John's the question, you're Robert. John put a browser statement where Robert was trying to put a print statement. The browser statement did work, so I could take a peek at the data. Is that okay to do? John's typical approach to debugging is to look at variables using a browser. So
yeah, so that would be the other thing we could do. let's run this really quick. There are some other debugging tips. Oh. Capital B. Okay, it's not happy here. I can't remember exactly how to use this. I tend to be old school and use print statement. Oh, I misspelled it. That's it. Don't attempt to type and give presentations at the same time. Never goes cool. Okay, so if we look back at R, you know, it does give some information here in terms of what's happening. I don't tend to use this. Some of my colleagues use this browser statement more. I tend to be, I guess, old school and just print stuff out. It's probably not the most efficient, but it's the kind of the way I've learned to do things. Okay, so that's our reactive statements. I know there's a lot going on there. Is there any other questions in terms of what we've done there and what we've added before we move on?
That's clear. Just for clarification, could you repeat the why was the reason we were using parentheses curly with the statements, like in general?
So in general, it's because that's how they're, oh, repeat that. So why, the question was for why for some things like these reactives, we need to use the parentheses in the curly brackets instead of just, you know, just the parentheses. So to some degree, it's how they're defined, the functions in how they're defined to be used. The other thing, there is actually some options that you can add beyond the curly brackets. So we're going to be, one of our later examples, we're going to add an option where like there are some additional arguments you can add beyond here. And then, so the curly brackets are kind of a fence around kind of the, if you think about how you define a function, you know, you can have a bunch of steps in there. So all the steps that you want to do are going to be contained within the curly brackets, and then you can add some options outside of that. So think of some of these like less like calling a function and more like defining a function. Good question. Okay, so I know this was one of the earlier questions and people are interested to talk about it, but so how can other people see my apps, aka hosting? So right now, all we've been doing is examples of running R Shiny on our own computers, our own laptops. But in order for other people to run your apps, they need some way to access the computer where the app is running. So generally speaking, your or my personal computer is not set up to do this well because it has to have kind of incoming and outgoing traffic to do this. Instead, this is a task that's really for a server component, different from our Shiny server, but a physical computer that is made for kind of this networking traffic. This could be your own on, you know, your place that you work for, your school, or someone else's. I'm thinking of, you know, in the cloud, someone else's server that you're paying to rent. So let's talk about some options that we have here. So the first option is the open source Shiny server from Posit. It's a way to freely host your app on your own server, or for example, I've never done it, but I've seen some examples of, you can buy/rent, Amazon Web Services or some other service like that to use a server. So this is great. It's free. It has some limited functionality and some scaling issues because it is the open source free version kind of this service. It only, I believe, allows kind of 1 R computation at one time. So if you have lots of users hitting your app at the same time, there's kind of a wait between things happening on the back end. But it is free, and so like if you don't have a lot of traffic, you don't need a lot of options. It's a great way to host your app if you have your own server or have the ability to rent that in the cloud.
What about, for all of these, I think I would have this question, what about like data security and confidentiality? Like, are certain of these only for open data or?
Yeah, so the question was about data security or confidentiality. So there are we'll talk about some things about password protection, things like that. I'd say for where your actual data being stored on the server. So that really depends, on your IT department, what they're comfortable with. Your server may be fine for sensitive or PHI information, for example. I know that some servers are rated for them and some are not. I'm not a networking expert in terms of like the options for incoming and encrypted traffic and all those kinds of things. So I would say if you're interested in setting this up, definitely talk to kind of your IT department to get all the best options to make sure they're okay with it. But I know at my work, we started off with this open source Shiny server when we initially set up our server, and we're using that. Second option, what's called Posit Connect. So Posit, who make our Shiny, have a paid service for hosting apps on your own server. So this is a software that you install on your own server, which allows you to host it on the web. This has a bunch of additional features beyond just hosting our Shiny apps. So you can build APIs in the background, as well as there's usernames and password protection that is built into Posit Connect. You log in as a user, and then you can control what each user, if you have multiple dashboards or multiple apps, you can control which users have access to which apps. But so it's very easy to use, has lots of features. You can also have a service contract. So if you have any issues setting it up or need some help on that kind of thing, that is available. The downside is just that, for some organizations, this can be expensive because you do get a lot of these nice features, and you do at least when I've used this before, and you needed to pay kind of by the user. So if you have a circumstance where you have a password protected app that you want to use, or you want to limit who can access the app, and you need hundreds or thousands of users, you need to specify kind of exact users for each of those. So that can add up in terms of the cost for this, but it's a really nice product. It just, you have to pay for those nice features. So that's the second option. Third option is shinyapps.io. So this is a way to host an app in the cloud. And the way this works is you pay depending on the cost, depending on how many hours are used and it's free up to 25 hours per month. So you kind of pay based off of these tiers. This is good for hosting apps where you don't have sensitive data and you don't need password protection. because, you know, this is, you're sending, your data has to live on somebody else's server. So there's some issues with that if you have sensitive data, usually. And I don't believe there is a way, a native way to have password protection. There are ways to build password protection into your RShiny app itself. I don't think we're going to cover that today, but that's kind of something you can do as well. So it's free or inexpensive for small amounts of use. It does lack some customization if you need your landing page to look a certain way or things like that. And your data is in the cloud. So I've actually pushed what's going to be our final example of our dashboard to shinyapps.io. Let's zoom in here. So this is what it looks like. So we'll see if we run out of free 25 hours, depending on how many people access this online. But for now, it works. So this is what our final dashboard is going to look at, and just a preview of some work we're going to add in here towards the end in terms of the counties and maps. So that is an option, free to some degree for some tiers, and then you have to pay depending on how much usage is there. The last option that I have for us is something called Shiny Proxy. So this is an open source method for hosting our Shiny apps. It is based on building Docker images of your RShiny apps. And the way it's set up is it allows it to scale a lot better than that first option we had, that open source Shiny server. It's free. There's a little bit of caveat for that, because Docker in some circumstances is not a free service anymore. For some organizations it is, for some it's not. But it does scale a lot better than that first option. There's a lot of customization, and there is password protection you can build into that as well, and usernames. However, the downside here is, because it is an open source method, you need kind of a high level of expertise to execute it, both kind of from the IT side and from the user side, because you have to build Docker images of your RShiny apps.
And when you say scaling here, are you talking about in terms of like traffic, or are you talking about the complexity of the actual app?
So this is in terms of the number of users that can use your apps.
So if you get big spikes in, let's say you get, I don't know, you get big spikes in traffic or something, this is.
Yeah, so it's gonna, so the way this functionally works, so as opposed to that first option, the open source RShiny server that we talked about, that has kind of there's one R process happening at a time. So if you got a lot of users, it gets backed up. What actually functionally happens with Shiny Proxy is every time a user goes to your app, a separate user, a Docker container gets built for that user. So every user is on their own instance of the app. Now, the limitation there is basically how big your server is in the background of how dividing those resources, but it is going to scale a lot better than some of the other methods. And there's kind of methods within Docker for balancing user load and that kind of thing, if you really get into it. So this is actually the option that I use, or we use at our work at the Government Resource Center. At one point, we started off with the open source Shiny close to 10 years ago when we first rolled some of this out. We did move to the paid, at the time, our Studio Connect service, but we got to a point where we were having a lot of users and it was getting more expensive to go that route. So actually me and one of our IT folks, developed this, found this Shiny Proxy method, and I learned to use Docker images to make that work. So it does take a little bit more expertise on the Docker front, but it's fun things to learn as well.
Do you have a rule of thumb about, like how many users are we talking when you would graduate from one to the next, just Just as a rule of thumb, like I said.
I think that the first option, I think this probably, if you start getting beyond like a couple users, this could really slow down. So if you're in a circumstance where like maybe at most you ever have 1 or 2 users of your app at any time, this will probably work great. But if you get into a circumstance where you might expect, 20 or 30 or 40, we load tested our Shiny Proxy version a couple times where we had kind of all of my colleagues log into the app at the same time to see what would happen. It works well. And then, the paid accounts obviously probably work the best in terms of using the number of users as well. And some of it depends on your server itself, how many kind of cores and just resources your server has to meet the demand.
We've got one that came in. I don't think there's a question here, but let me just read this and you can react if you want to. This person says he was going to ask, what are the best practices for freezing the environment for a Shiny application? And if Shiny Proxy sort of does that by a Docker, that seems great. He says that his current Fed job and that private sector job, the POSIT solutions were way too expensive. So again, I think he's just kind of confirming what you're already saying, but if you have a reaction, go ahead.
Can you repeat the part about freezing?
He was saying what he was going to ask. It sounds like he was going to ask this question until you covered it. He was going to ask, what are the best practices for freezing the environment for a Shiny application?
Yeah, so one thing, so in terms of, I think I'm going to interpret the word freezing in terms of kind of making things stable, in terms of one thing that can happen a lot of times with R, right? We have libraries that we're using. We tend to use, there's a lot of libraries that we're going to eventually use in our Shiny apps. There's versionings of those libraries, there's versionings of R. And so one thing that you have to watch out for in a production setting is, using different version. I'm testing on this version of the library versus, or the package or R, and then I'm actually just in production, something happens where I'm using a slightly different version, and then bad things happen, right? So in the POSIT, and I believe the Shiny Apps IO options, they have built in some options that will grab whatever versions of packages you are using when developing or you have open at the time, and it will use those in the app. So they have some nice things to make that work well. With Shiny Proxy, you have to be a little bit more deliberate of this when you're building your Docker images. So what I know we have done is, how these work with the Docker scripts is, you basically have to, it's just basically directions. You build these Docker files of directions to essentially build the system that runs the app. So you have to be really deliberate about versioning of R and packages within that. So we've done pretty well in terms of, instead of just saying install packages XYZ, you install a specific version of all the packages you want to use, and that way you can maintain that stable environment rather than pulling the latest versions of things. Always, you need to kind of have a specific version so that you don't run into unexpected issues.
And he's confirming now that this is what you meant and you covered it. So thank you.
Yeah.
Could you use like for example, when you are building R packages, you can use something like Packrat. Could you use that for Shiny too?
Yeah. So the question was, there's some kind of package managers. I think that's the right word. Package managers that help you. One was called Packrat. I've tried using some of those at different points in time, and I found them a little bit tough to use. It didn't work perfectly. I feel like Packrat might have been deprecated. There might be a newer
I think so,
version
I don't
of that.
know the newer one. Do you know package name?
Yeah, I remember there is newer ones, and Posit RStudio has also rolled out some pay for things to help you manage packages, resources. I found, you know, in production settings, if you have the expertise to try out this Docker method, that works really well in terms of that stabilization and those packages. But those options like Packrat or those package managers, I think internally that's actually what like the Posit Connect and shinyapps.io. This is run by Posit, I believe. I think that's internally what happens when it packages up your app to deploy on the server or the website. So those do work with it. And I'll also say this shinyapps.io, super easy to use from RStudio. They made it really easy, kind of push button once you set up your account with them. So a good option as you're starting your R journey.
I have a question for the Shiny Proxy. I'm just curious, how do you also share a website with your user? Like, do they also access through like a web?
So basically, right, so this is, you have your own server, you kind of run this, you'll have a website that you'll need basically points to your server, and you can, you know, name that different things depending on, this is the networking stuff, which I don't have a great understanding for, but basically it's accessing your server, and then like a path within your server will point to the individual websites.
You've had it up, I think, with I think it was the option 3. I think you had shown it an actual URL.
So yeah, so this is the Shiny Apps, the Shiny app, or the shinyapps.io version. So this is the URL for that. The Shiny proxy, yeah, will basically point at your server. If you want to, I can plug more my work. Version, if you want to see that Shiny proxy. Let's see if this works. Okay, maybe I'll try to get this up and working in the break. But yeah, it would just be a website and that you host from the server, and you need like the domain name and stuff like that. Okay, any other questions on the hosting before we move on?
We had one question. It's not about hosting. It's kind of back to more about the building the app. Let me try to scroll through that one. It was about something called Rhino, which if you haven't heard of, you can probably put it to bed right now. But
so I believe, I haven't delved into that. There's starting to be a couple like packages that are like frameworks for building our Shiny apps, which are kind of follow, you know, the steps within this framework, and it kind of helps you build those. I haven't personally tried to dive into those too much, but I think there's some good options to explore using.
This one said, I mean, he's saying like, have you found any advantage or value of using packages from Epsilon to develop Shiny apps such as Rhino? And then he was saying he likes the organization of the files and so on. And he wonders if he says, I wonder if Shiny modules and using techniques such as the Rhino framework have ever entered your app development process.
Yeah, so when I build our production apps, I do use what's called Shiny modules, which basically, so we have those like our different tabs in our navbar page that we talked about, which basically means Shiny modules is a way of splitting up the code into different chunks to do that. So I do use Shiny modules myself. I also tend to use, I think it's similar to the Rhino framework, a package called Box in R. If you're familiar with the way that Python imports its libraries, it's very parallel to that. It makes it so you can a little bit easier, rather than using like source functions within R, to directly call functions from other files. So I split stuff up with those two tools, and I think that is very much in the same kind of general framework as kind of some of these other, the Rhino package. I kind of just do that manually in my own way. And I actually had a colleague, I think, that talked to some of the Absalon folks at one of the recent POSIT conferences, and it seems like that is very much in line with the frameworks for those different kinds of things. So I haven't put that in here specifically, but yeah, it's the box package and the Shiny modules is a kind of advanced R feature. Okay. So let's jump into accessibility with R Shiny. Okay, so I first want to give credit to Neil Hatfield. He had a recent talk at the joint statistical meetings that I attended that was really great. I got a lot of information in terms of accessibility for Shiny apps. So credit to him for a lot of this information. So, you know, the great thing we've talked about Shiny is it allows ways to make these interactive web applications. We don't have to know HTML, JavaScript, or, you know, how things work more generally. There is a downside of that in that when we're developing these things, we might not always know what our best practice is for meeting accessibility standards on the web. So on one hand, it makes it really easy to make web applications. On the other hand, we may not know how to do those things well to meet requirements. So I'm going to point out that there's these this web content accessibility guidelines to check out if you're doing this in production. Additionally, you know, if you're at an organization like the University of Michigan, Ohio State, we have our own guidelines in terms of accessibility that we're supposed to meet for any materials we put online. So it's important to keep that in mind as you're kind of producing web apps that may be through your university or academic institution to make sure you're meeting those accessibility guidelines. So let's talk about some tools and some tips that can help us. So the first thing I'm going to point out is this Wave browser extension. So Wave is a suite of evaluation tools that helps us kind of figure out, you know, where we're doing okay and where we're not doing okay in terms of accessibility. So I'm actually going to be using this Wave browser extension. We'll do a little demo for Chrome, but in general, you know, there's some different tools here from this organization that allows evaluation of your website in general. So some of the things we're going to focus on, kind of maybe low-hanging fruit for us to make things improved in terms of accessibility. The very first thing is actually defining a language for our web app. So screen readers like to know what language they're trying to read. So we need to tell it that explicitly, and we actually can do that really simply by adding an optional argument to our navbar page or our other UI feature. We just say the language is EN-US for English, for US English. And that allows that screen reader to know what to read. The second thing is to use HTML tags. So this is in the bonus content at the end of the slides where I talk more about HTML tags, but different levels of headers, lists, just kind of properly using those things to guide a screen reader around the screen. The third thing here is meaningful labels for inputs. So we had that argument in our UI components. That was that label argument, and that shows up on the screen. But it also shows up kind of on the back end I think for screen readers. So being really meaningful about using that, and because it goes along with the UI input. And then The last two are thinking about color contrast for our apps. Just there's some, if you look at those accessibility standards, there's some standards around contrast for text versus the background, just to make sure it's easy to see. And the last thing is, which is a little bit harder, is planning for alt text for our graphics. So alternative text, and we'll see some ways we can do that. So there's two general ways to implement alternative text. So this is an example we talked about just earlier. The first general method we talked about earlier, where in our render plot, why we have the parentheses and the curly brackets. So this is an example of one of those optional arguments we can put at the end of that. So in our render plot, as part of our survey or of our server, we can have the server code that creates the plot, and we can add an argument at the end of this, which is an alt text that will go along with the plot. The second method, if we're specifically using ggplot, there is an alt text argument that you can add as part of the labels in your ggplot. And that's just this alt equals. So I think what's a little bit more challenging, what is both an opportunity and a challenge, is thinking about dynamic alt text. So, right, so we have lots of inputs that can change. Our plots aren't always static. It can be hard to write a general description of a plot that can be changing. So I think that's like an open question of how to do that well. But we can have a good faith effort in terms of trying to describe, at least the inputs that go into that, if not trying to figure out a way to dynamically describe the output. I think that's harder. Okay, so now we're going to try to apply this to our app. So we're going to look at example 11. We're going to add a language. We're going to adjust the theme to fix the contrast error and add alt text for our plot. And I'm realizing that I forgot to test the Wave browser extension on our actual app. So we're going to do that first before we apply these changes. So I'm going to go, don't save. I'm going to go back to our latest example, which was example 10. And let's test out our browser extension. So I'm going to go to this page. Oh, something's not happy. Okay, so let's test out our browser extension here. All right, so this is what it looks like. So, right, this is our default app before we changed everything. So we get this summary on this left-hand side. It tells us we have one error and two contrast errors and some other alerts. So if you click on details, you can get a little bit more information on this. So this one first here, right, it's telling us we have that language missing or invalid. So this is where we didn't specify what actual language, English, French, German, Spanish, that our website is in. Good news is we know how to fix that. It's also telling us we have contrast errors, specifically like around the top part of our dashboard. This is interesting, I think, specifically because we are using the default options for the default theme. So it means the default theme for our Shiny doesn't necessarily pass these contrast errors, which is probably not ideal. We also have some alerts. I've tried to figure out maybe what these are. So we don't have any heading structure for our page. So those are those HTML tags necessarily. but then some green check marks, which is good. I will say I'm very new to using this tool, so I don't interpreting it. I'm still working on. So, but this can be used on any web page in general as well, I believe, not just our Shiny apps. Okay, so, right, we said we wanted to fix these things now. Add a language, adjust the theme for the contrast error, and try adding some alt text for our plot. So let's look at example 11. So we're going to set this as the working directory. Okay, so the first thing we've done here, right? Very easy. We're going to set the language in as part of the navbar page as English, US English specifically. That's really easy to do. The second thing to fix the contrast errors, rather than trying to do this, you know, maybe more directly in terms of the shades of gray and black that we're using, I found a different theme called Spacelab, which seemed to have better contrast properties that pass it. So I'm just adding a theme onto our app to do that. The next thing, the last thing that we talked about here was adding alt text for our plot. So what I've done was to, let's see where I added this. Okay, so I created a new reactive text kind of reactive object that is going to be our alt plot title. Similar to just the title of the plot, but I've been a little bit more comprehensive in terms of what it says. So I've actually made this a reactive object. So it's going to say a bar plot comparing the rate of whatever outcome we choose in the given year by the California county. So it's going to give a little bit more information than just it's a bar plot, right? But it's not going to go all the way of trying to say like this county had the highest, this had the lowest. But you know, you could do that in your app. It would just take a little bit more work to actually do the computations of finding the counties that was the highest, or some sort of description to describe it. But it's all possible, just more work. And then what I did was in global, I added an argument in ggplot with the labels. That is the alt title that's going to come from defining it there in the server.
We've got a quick question. What does alt text mean?
So alternative text is going to be, so if you're vision impaired, this is going to be what like a screen reader will tell you the image is about. If you're not able to see it.
Sort of like a verbal description.
Yeah, verbal description would be a good way to put it.
And it would apply to just pictures, or does it apply to every element on the page, or?
So I think the idea is just pictures. So text elements, the screen reader should be able to read the actual text, but and I guess I'm not totally sure. I think tables probably similarly, but it's, I think specifically like graphics that need alt text.
Great.
Yeah, good question. Where did my button go to stop? Okay, so let's run our new example with all our additional features. Okay. And oh wait, I think I got the wrong one. I think we need to go to 12. Oh no, this is 11. Okay, so we can try this browser extension again to run this. All right, so we no longer have our language error. You see it says EN US up here. And our contrast errors went away with this new theme. And you can see, okay, so here it says, it highlights that alt text that we created dynamically down here, a bar plot comparing the rate of deaths due to all causes in 2021 by California County. Okay, any additional questions there?
Yeah, we did have one, this one's actually going back to hosting, if you're willing to go back that far. Let me go hunt this down again. Okay, so this is in regards to Shiny Proxy, which I think is your option 4. The question is, what kind of expertise is needed to set that up? Do any of the framework packages or others simplify setting up Shiny Proxy and hosting, e.g. in a research lab setup with no IT expert support? So, I mean, which is obviously probably very typical, but.
Yeah, so I don't believe any of the actual like frameworks for building the apps help you at all with setting that up, that I'm aware of. I think, you know, if you were to want to get into Shiny Proxy, I think it's teaching yourself Docker, which I did to do it. And then, you know, I think the networking stuff, you know, you'd have to teach yourself to do some of that as well if you can't find a resource to help.
Do you have thoughts on whether the other options are easier for setup?
Yeah, the other options are definitely going to be easier. I think the first open source method that we talked about, the Shiny server, like there's specific directions online for how to set this up on your server. There is for Shiny Proxy as well, but these are probably a little bit easier. Still, you know, this is some, you know, more advanced kind of IT work than, you know, your typical statistician or data scientist might know in terms of working on servers and the networking piece of this, but there's some good instructions here.
Great. Back to the accessibility section. This person just asked, how did you put the Shiny browser into Wave? So could you just demonstrate that again?
Yeah, so all you need to do to use this, these are all our dead versions. So you just go to any web page. And so our dashboard is just another web page. You do have to specifically go, I think, to the certain part of it. You can't actually move around within the app once you've enabled the tool. But I've installed the browser extension here. I'm using, what am I using? Firefox. Once you've installed it, you know, Firefox just has this button for extensions, and you just run the extension, and then it shows up. Okay, great. Let's take another short break. I can tell I'm losing a little steam. Everyone's losing a little steam. So we'll power back up with, you know, more coffee or a break. And let's restart right at 12. And then we'll hit our last section on advanced features.